Hi, I'm Noah, and I'm a rising junior at the Birchroth and Lennox School. My project is a CNC pen plotter, which is basically a drawing machine. Um, so for my third milestone, I constructed the base of the project. It's made out of T-bar, many brackets, particle board, and wood. The T-brackets go in between the particle board and the wood, which stands it up as a railing for the pen carrier to slide vertically up and down the board. This pen bracket slides horizontally left and right, and the combination of the two allows the pen to move any way it needs across the board. The use of brackets, timing pulleys, and a timing belt is what allows it to move. There are two motors mounted underneath the board here and here. The rest of the timing pulleys are mounted on brackets, or in this case just directly to the wood. Using the core XY theory of Cartesian motion, the belts allow it to move in any way it needs to across the board, so that the pen can draw anything it needs to at any place. I had a very difficult time with the brackets because I was using 18 gauge aluminum and the brackets kept breaking, or the I would drill the holes slightly off, and this project requires a lot of very precise mechanics, and mechanics is something that I've always struggled with. I've always preferred electrical, struggled with coding. So it was a really big challenge for me to choose a project that was so heavily focused on the mechanical aspect. But it was a huge challenge, but I learned a lot. I learned how to use all kinds of tools and became a master at folding brackets and drilling into all kinds of materials. And so those are not only good skills to have for engineering, but also good life skills to have, because if something breaks in my house, I can fix it myself instead of having to call someone to fix it for me. Unfortunately, because very specific and advanced parts are needed for this kind of project, with the tools that we had available, not everything worked as it would have had we had access to some more advanced and expensive materials. So the brackets were not sturdy. A combination of friction and lack of torque in the motors made it difficult for the belt to move, and the brackets were there was too much friction in the brackets for this to move as smoothly as needed. But I worked on the conceptual aspect, the math, and the theory, and so everything works perfectly, minus the motors actually controlling everything. So everything moves as it's supposed to. Everything, the timing belt moves it where it needs to, when it needs to, very easily. It's once the motors have to do it by itself is when the friction and physics kind of get in the way. But that being said, I can still move all the belts and turn the motors with my example code, and everything is put together as the best possible way as it could have been with the materials at hand. And so I can show you it moving. So this belt that you can see moving would be attached to this pen bracket. Unfortunately, we didn't have time to connect it in a stable enough position for it to move, but it would move this pulley horizontally left and right, allowing the pen to move, and also, if it had enough strength, move the pen carrier forward and backwards across the machine. It was really a big challenge, but it was really interesting and I learned a lot. Yeah, thank you.